Welcome! In this section, we'll be looking at the graph processing with GraphX library. In this section, we will look what the graph really is and how to present graph in programming language, for example. Then we'll be using GraphX in Apache Spark. At the end, we'll be performing structural operations that use edges and vertices in graph and neighborhood aggregation. In this first video, we want to answer a question what a graph really is. So first question is of course what a graph is, and we will explain what graph is. We will look where it can be used, and we will present that graph in a graphical form. Data scientists come in all shapes and sizes and from a remarkably diverse set of academic backgrounds. Although many have some training in disciplines like computer science, mathematics, and physics, other successful data scientists have studied neuroscience, sociology, and political science. Although these fields study different things like brains, people, political institutions, and have not traditionally required students to learn how to program, they all share two important characteristics that have made them fertile training ground for data scientists. First, all of these fields are interested in understanding relationship between entities, whether between neurons, individuals, or countries, and how those relationships affect the observed behavior of the entities. So graph is a relationship of entities. Second, very important thing is the explosion of digital data over the past decade gave researchers access to vast quantities of information about these relationships and required that they develop new skills in order to acquire and manage those datasets. As these researchers began to collaborate with each other and with computer scientists, they also discovered that many of the techniques that they were using to analyze relationships could be applied to problems across domains, and field of network science was born. Network science applies tools from graph theory, the mathematical discipline that studies the properties of pairwise relationships called edges between a set of entities called vertices. Graph theory is also widely used in computer science to study everything from data structures to computer architecture to design of networks like the internet. So two main components in graphs is vertex and edge. Graph theory and network science have had a significant impact in the business world as well. Almost every major internet company derives a significant fraction of its value by its ability to build and analyze an important network of relationships between any of its competitors. The recommendation algorithms that are used at Amazon and Netflix rely on the networks of consumer item purchases, Amazon for example, and user movie ratings, like Netflix, that each company creates and controls. Facebook and LinkedIn build graphs of relationships between people that they analyze in order to organize content feeds, promote advertisement, and broker new connections. And perhaps most frequently and famous of all, Google used the PageRank algorithm that the founders developed to create a fundamentally better way to search the World Wide Web. The computational and analytical needs of these network-centric companies help drive the creation of distributed processing frameworks like MapReduce, as well as the hiring of data scientists who were capable of using these new tools to analyze and create value from ever-expanding volume of data. One of the earliest use cases of MapReduce was to create a scalable and reliable way to solve the equation of the heart of PageRank. Over time, as the graphs becomes larger and data scientists need to analyze them faster, new graph parallel processing frameworks like Pregel at Google, Giraffe at Yahoo, and GrabLab at Carnegie Mellon were developed. These frameworks supported fault-tolerant, in-memory, iterative, and graph-centric processing, and were capable of performing certain types of graph computations order of magnitude faster than the equivalent data parallel MapReduce jobs. In this section, we'll be looking at a Spark library called GraphX, which extends Spark to support many of the graph parallel processing tasks that Pregel, Giraffe, and GrabLab support. Although it cannot handle every graph computation as quickly as the custom graph frameworks do, the fact that this is a Spark library means that this is relatively easy to bring GraphX into your normal dataset analysis workflow whenever you want to analyze a network-centric dataset. With it, you can combine graph parallel processing with the familiar Spark abstractions that you are used to working with. In this chapter, we are going to use Scala, Spark, and GraphX to acquire, transform, and then analyze the graph. So, first step will be to load data in Spark. Then we'll create a vertices and edges of graph in GraphX library. And then we'll be using GraphX API to perform data analytics.